is all about tree diagrams. So that's probability 2. It's page 195 in your book. Okay, we're just going to run through. It's quite basic, just the very start of it. So the basic premise of it is it can be used for stuff with 3 options, but it just becomes messy. But it's normally for when you flick a coin. You got 2 options, heads or tails. Or you take a penalty. You score or you miss. It's that type of way. If you're picking colours out of a bag and there's only red and blue ones, it's red or blue. So we'll start off with the heads or tails one in the beginning. You got 2 options, heads, tails. Simple. If I get a heads first time, nothing changes. I got heads or tails. And then I got heads or tails. So right now I've got 4 outcomes. Heads, 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 tails, tails, heads, tails, tails. Okay, and you can see they're 1 of 4 chance. Because, yeah. So if we do it 3rd time, you go heads, tails, heads, tails, heads, tails, heads, tails. Okay, so the top one in each time is heads. It might be hard to read that. Okay, so that would be heads, heads, heads. This might be, or this is heads, heads, tails. This is heads, tails, heads. This is heads, tails, tails. This is tails, heads, heads. This is tails, heads, tails. This is tails, tails, heads. And this is tails, tails, tails. Okay? So that's the premise of it. So if I came back to you now and said, what's probably getting all heads? Well, it's 1, 2, 3, 4, 5, 6, 7, 8 outcomes there. It would be this one at the top, and it would be 1, 8. Okay? What's the probability of me getting 2 heads? Okay? So the probability of 2 heads would be 1. This one here, that's 1. That's 2 heads, and that's 2 heads. So that would be 3 eighths. What's the probability of me not getting exactly 2 heads? Yeah, it would be 8 eighths minus 3 eighths. Okay? What's the probability of me getting at least 1 heads? I'll come along. That's 1, 2, 3, 4, 5, 6, 7, 7 eighths. So that's a really, really basic one there. And this, so when I'm flicking a coin, it's independent of the previous time. So every time I flick a coin, the outcome is different than the previous time. So what do I mean by that? Well, the first time I flick it, it's 50% chance it goes heads. Second time I flick it, it's 50% chance it goes heads. Third time, it's 50%. The previous outcome does not affect the next one. A different one would be if I'm taking drawn marbles out of a bag. Okay, there's red or blue. Well, the first time I take out a red one, if there's 5 red marbles out of 10, well, that's a 5/10 one. But if I've taken that out, I've only got 4 left the next time. Okay, so that's where it's about replacement. If it's replaced in the marbles, then it's independent. If it's not, it's not independent. Okay, I'll go through 1 or 2 others here now. So, well, second, let's just rewind for a second over if I said to you, what is the probability of getting heads, 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 or heads, heads, tails? You would then say that that's this one plus this one. 1, 8 plus 1, 8. Okay, so remember, OR is always addition. Always, 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 always. Okay, now, when we're coming to the next one, let's say I tell you, taking a penalty. Okay, so it's score, miss. Sorry, I need to put that up higher. So if I score, maybe it's 2/3 chance. It's 1/3 chance I miss. So next time, it's independent, unless the question stipulates otherwise. Yeah, and where it could stipulate otherwise is, would I say, if he scores his first penalty, then he's got a 4/5 chance to score in the second one. But let's say this is the same each time. So that would be 2/3. That'd be 1/3. This would be 2/3. That's 1/3. Because scoring is always 2/3. So the outcomes here: score, 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 miss, miss, score, miss, miss. Okay. So the chances of scoring is 2/3 multiplied by 2/3. Because it's score and score. So whenever we're looking for that, it's multiply. And means multiply. That's 4/9. This is score and miss. So that is 2/9. This is miss and score. It's going to be the same. This is basic stuff here. This is junior cert stuff. And that's 1/3 by 1/3 because it's miss, miss. That's 1/9. Okay, the difference between this one and this one is that the probability changes depending on which outcome we get. Score or miss, the probability is different. Now, they are both independent of the previous one. Okay? Right. So, next. If I gave you something that wasn't independent, so if I said to you, John's taking a penalty, score for the first one is 2/3, and miss obviously is 1/3. You have to apply a bit of common sense there. If they say scores 2/3, obviously miss is 1 minus 2/3. Now, for the second penalty, if he scores the first time, if scores first, then it's going to be score is 4/5 and obviously miss is 1/5. But if he misses, it's going to be score is, for the sake of this, we are going to say it's going to be 50/50. Okay, so the miss is that. And that is kind of true in real life. Somewhat, not fully, but kind of true. So we come along to this then, and I say, John scores, John misses. Score, miss, and we're saying he takes 3 penalties. Score, miss. Score, miss. Score, miss. Score, miss. Score, miss. So on each one of these branches that come out, the top ones score, the bottom ones miss. Okay? Right. So I said for the first one, it's 2/3 and it's 1/3. Okay? I said if he scored the previous one, he's got a 4/5 chance of scoring the next one. And he's got 1/5 chance of missing. If he miss, it's 50/50. It's 1/2 each way. Now, if I said, so this one again goes to the third time. So this is the first panel, this is the second panel, this is the third panel. The third panel, he scored the previous one, so he's got a 4/5 chance, and he's got a 1/5 chance here. This one, he's got a 4/5 chance, and he's got a 1/5 chance. Or sorry, whoop, that's me getting ahead of myself. This one, he missed. So if he misses, he's got a 1/2 chance and a 1/2 chance. Because we said if he misses, chance of scoring is that. Now, this one he's scored, so he's back up to 4/5, and that's 1/5. This one here, he misses, so it remains at a 1/2 and a 1/2. So, always write out the possible outcomes. That's score, score, score. This is score, score, miss. This is score, miss, score. This is score, miss, miss. This is miss, score, score. This is miss, score, miss. Miss, score, miss. This is miss, miss, score. And this is miss, miss, miss. So outcomes 1, 2, 3, 4, 5, 6, 7, 8. So the 8 outcomes. Now I do not say that score, score, score is 1 in 8. If I was looking for the probability he scores 2, Okay? 2 penalties scored. Okay? I would then come along and I'm going to put in circles for the 2 penalties that he scores. And if it says exactly 2 penalties. If it said at least, I'm including the top one, we're saying exactly. That's 2. That's 2. So there's 3 outcomes there. And all the probabilities are going to be the same, but we'll work, or sorry, they're not all going to be the same. So we go to the first one, it's 2/3. The next one is 4/5. And then the last one he missed was a half. So he scores 2/3. The next one he misses is 1/5. And then the next one he scores is 1/2. Then the last one we come here. So that refers to the miss first. That's 1/3 multiplied by a half multiplied by 4/5. So they're all different probabilities because it's the sequence in which it goes. Score, score, miss is different than score, miss, score. Even though it's still 2 scores. And that's 8/30. And this is 2/30. And this is 4/30. So it's this probably plus this plus this. So that's 14/30 is our outcome there. Which would mean that if they came straight away and says, what's the probability he doesn't score exactly 2? You would say 16 minus that. Okay? 16 minus that. That's the basics of this. And all the questions are pretty simple. When you look at question 5 on page 198, on page 5, there's 3 different outcomes. But they only get you to do it twice. So you're only doing it twice. They would never ask you to do it 3 times really for 3. It would just get really, really sloppy. As you can see already, this here gets a little bit sloppy. They don't really get you to go beyond that. But the questions are simple enough. If you go to question 10, it says, on his way home to work, Nick goes through a set of traffic lights and then passes over a level crossing. Over a period of time is estimated the probability of stopping at each one of these. So, at the traffic lights. So this is question 10. So, our 2 outcomes. He estimates he's got to stop at the traffic lights, not stop. So he says he's got a 2/3, and that's 1/3. Okay? Then the next one is the level crossing, and we're told they're independent of each other. Now, you've got to see, so this is stopping at the level crossing, not stopping, stopping, not stopping. You've got to say, okay, is that independent? Does the first one affect the second one? No, then it's independent. And stopping at that is 1/5, not stopping is 4/5. 1/5, 4/5, that's stop, 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 not stop, not stop, stop, not stop, not stop. Okay? And construct a tree diagram, perfect. Calculate the probability will not stop at either the lights or the thing. So, not stop, 1/3 multiplied by 4/5. And that's 4/15. Now, when you're doing your work at home, go through all of these questions. I think it's quite reasonable to get through today. There's 12 questions in the exercise. My advice is to go through all of them. It will not take you long. Post it up and to Microsoft, or email it on to me, and I'm going to email you the solutions if you need them. Okay? I'm going to generally set up, or I'm going to send on the solutions from now on if you want. Okay, so best of luck with those, and I do not see them causing much trouble for you. I'll actually run through one more example for today, because I'm getting used to doing this here. Okay, if you look at example 1, okay, so in example 1, you've got red or you've got blue. Now, the chances of getting a red, it's in box 1, is 3 out of 7. and then obviously the blue is 4 out of 7. Yeah. Now, I'm going to change this question around ever so slightly. Let's say if we went from the same box. Okay, the chances, I think everybody would agree that when we begin, we've got 3 reds, we've got 4 blues, and now we have start off with 7. We would be left with 6 options here. We have already picked out a red, so I'd have 2. I'd be still left with 4 blue. If I picked out a blue, I would be 1 blue left. I would have the same amount of reds in the beginning, because my first one was blue, and there'd be 3 out of 6. This will go down to 6. I've picked out a blue, so the 4 drops to 3. My options are red, 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 blue, blue, red, blue, blue. Write them out. That's 3 over 7 multiplied by 2 over 6. That's 3 over 7 multiplied by 4 over 6. 4 over 7 multiplied by 3 over 6. And that's 4 out of 7 multiplied by 3 over 6. Okay? Hopefully that will help you do all of them. Hope that this is not too confusing to follow online. Okay? Thank you. See you now. Bye.